So back to notes. Since I forgot to record at the beginning of the lesson, this is Unit 5, Day 3. Unit 5, Day 3. I know you are. Unit 5, Day 3. And we have already used our theorem sheet and talked about the side congruence postulate for proving triangles congruent. If three sides of one triangle are congruent to all three sides of another triangle, then the triangles are congruent. So now we're doing our first proof on proving triangles are congruent. And we are given that side KL is congruent to side LN. And we wrote it down in our statements. And we have marked it on the picture. Then my second given is segment KM is congruent to segment NM. And that's not marked either, is it? And since I've already used one tick mark, I'm going to use two tick marks to differentiate. I'm trying to, that those are congruent as well. Okay. And those are given. So my first reason is always given. I want to prove that the triangle KLM is congruent to triangle NLM. Now, we talked briefly on the last day we were at school, which is Thursday, I think, that when we write a congruency statement like that proof is, the corresponding parts in there are in the same position, right? Right? Angle K matches to angle L. Angle L matches to angle L. Obviously, it's the same angle. Well, they're not. They're different angles. And angle M goes with M. And also the segments work. Segment KL is congruent to NL. LM is congruent to LM. And KM is congruent to NM. Right? We talked about corresponding parts. All right. Now, side is the only congruence postulate I know. Right? So far I have two sides are congruent to two sides. So somehow I've got to show that the third sides are congruent. Now, what sides are not marked for each triangle? LM. Well, don't both triangles have the same segment? Yeah. Can I say LM is congruent to itself? By what reason? Reflexive property, yeah. So they share that side LM. So I can say LM is congruent to segment LM because they're the same thing. So that is the reflexive property. So we said that we would use that later. Well, we're using it now. This is the unit where we start using reflexive property a lot. So now I have 1, 2, 3 sides congruent to 3 sides. So now can I say the triangles are congruent by side? Yeah, if 3 sides are congruent. If I have said in my statements 3 sets of sides are congruent to each other, then I can say the two triangles are congruent by side. Make sure your proof matches exactly the last statement. So copy the proof. Triangle KLM is congruent to triangle NLM by side. And all you have to do is write SSS. I'm trying to, it's not letting me. So if they share side, always use that reflexive property. Okay? If the two triangles are stuck together like that, show that side that's congruent to itself. Don't just omit that and say, look, they share a side. You have to actually use the reflexive property. All right? Write it in there in your proof. All right? And always look for that because that's an easy part of a proof right there. Any questions about that proof? Side. Pretty basic. 3 sides are congruent to 3 sides. All right. Easy proof. To me, triangle proofs are the easiest ones. I don't know why. I like them better than parallel even. Parallel's good, but. All right. You see how this is a rectangle divided into triangles? Yeah. Now, they didn't really state out any givens, did they? No, but they did give us the picture, right? So y'all draw that picture. And after you draw the picture, go ahead and write you a statements and reasons table. the first thing you're going to do when you get your quiz. Put your name on it. Put your name on your quiz when you get it. So it is multiple choice, multiple response. Now, what is multiple response?
I'm gonna check them out as we do.
There's more than one correct answer. Pay attention for those problems. Right? Pay attention for those problems. Capital letters in the blanks out in front of the number. Do multiple choice mean? Do multiple choice mean that don't work? What do y'all think we can write down for our given? Not angles. Okay, give me one. Segment AB is congruent to segment DC, right? Something else? Very good. So both pairs of segments are congruent. And those are marked, okay? The short ones have one tick mark and the long ones have two tick marks. So those are given to me, even though they didn't say it in a given. The picture is good enough for the given. And I'm going to write picture in parentheses in case you're looking back at your notes and you get confused. All right. Looking at the picture, is there anything else we can say is congruent?
And segment DB is congruent
To what?
to itself.
To itself, right? You see how that diagonal splits the rectangle and both of them have that segment in their triangle? So there we go. So segment DB is congruent to segment DB. What property says I can say something's congruent to itself? Reflexive property. So always look for them to share a side and use reflexive property. Now do I have three sides congruent to three sides? Yep, so now I can say triangle ABD is congruent to triangle CBD. Because of what reason? Side, side, side. Three sides are congruent to three sides. All right, any questions about side, side, side? Y'all, if you're using side, 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 it's mostly going to be something to that effect. All right. This one's slightly more complicated. They give you a lot of givens, though. Give you a lot of givens. Can't even read that. AC is congruent to CE. AB is congruent to AD. And E is the midpoint of segment BD. So if y'all want to just write that all in a table and go ahead and start your proof with it, that's fine. Just draw the picture. So if you're doing one of these on a worksheet, it might actually split up all three givens into three separate givens. I don't like to do that. I like to do them all together. It might just take a few lines, but all of that is given. Like I said, if this was on a worksheet, they might, when you're filling the blank, they might split up and make 3 different givens, sprinkled all throughout your proof. But this is a short proof, so. Okay, so the only congruence postulate or theorem we know so far is side, side, side. So I have got to somehow prove that 3 sides are congruent to 3 sides. How many sides do we know are congruent so far? I have 2 sets of sides that are congruent, right?
Yes.
And then I have me a little clue to help me figure out the 3rd side being congruent. It says E is the midpoint of segment BD, right? So here's segment BD, the whole bottom base part here, this figure. E is the midpoint of it. So what does that mean?
Left side does.
That means these 2 segments right here are congruent, aren't they? All right, so that's my next statement. BE, segment BE, is congruent to segment ED. By what reason? Very good. That's a definition of a midpoint. Definition of a midpoint. So now do I have 3 sides congruent to 3 sides? I sure do. So now I can do my proof. Triangle EAB, which is the left triangle, is congruent to triangle ECD by side, side, side. Yeah. So this time we didn't use reflexive property, but we used that definition of a midpoint. Okay. So if they did tell you like a midpoint, you know, some more segments are congruent, or even bisector, right? Because a bisector does the same thing. You just do a definition of a bisector. Very good. Any questions on these? So far, triangle proofs are not too terrible, right? Now, what's going to get more complicated is when we start learning some more of the different congruence theorems and postulates. All right, here's side angle side. Find side angle side on your handout, please. Is it the bottom?
Yeah.
All right, good. So mark the bottom theorem. This is actually a postulate. All right, now this is what matters here. It's in order, side, angle, side. Okay? The angle is between the 2 sides. It's like a sandwich. All right? So it says the 2 sides and the included angle. That means the one between it. Okay? The included angle of a triangle are congruent to 2 sides, and the included angle of the second triangle, then the 2 triangles are congruent. Okay? So if you look right here, these sides are congruent to each other because they have 1 tick mark. The angle is between the other sides that are congruent. Okay? So if the angle is not in between it, that would be angle side side, which does not exist. Do y'all see that? Like if the angle was over here, it'd be angle side side. That does not exist. So the order matters. Does that make sense? Okay? So angle side, no, sorry, side, angle side. Okay. There we go. Okay. Looky here. What does this symbol mean?
Parallel.
Parallel. So if you don't want to write that given and just write the proof and you draw the picture and then do your statements and reasons table, that's okay. So this is a parallelogram, right? Right. And they showed that those segments are parallel on the picture by those little angles, didn't they? All right. So if they told me parallel but did not draw that in the picture, make sure you draw it in the picture. They did not draw my given segments. Yes, they did. They tell me BC is congruent to AD. Okay. So make sure everything that they tell you in the given is marked on your picture. Always, always. Because sometimes looking at your picture helps you do your proof more than anything when it comes to triangles. All right. Statements and reasons. BC is congruent to AD, and BC is parallel to AD. And those are both given. So this is a parallelogram, and AC is a diagonal that goes through it. Y'all see that on the picture? Okay, so this is going to be kind of similar to the rectangle problem we did earlier. Not exactly the same, but a little similar, right? The picture kind of looks the same. All right, except for it's specifically parallelogram. So what's something else? Can I say something else is congruent from my picture? Well, I only know one pair of sides that are congruent, so I'm either going to have to find 3 sides congruent or 2 sides and the angle between them, right? Either way, I need another side and at least another side and an angle. So tell me something else that's congruent to each other. AC is congruent to itself, right? They both triangles share side AC. Oops, I did not mean to erase that one that was already there. I think I put my pinky on it or something. Okay, so AC is congruent to AC, and that's the reflexive property. Some of my stuff erased. Did you say that D went away? Sugarfoot. I turned you black. Where are you going? There we go. All right, so now I've got 2 sides congruent. We haven't used that information about those being parallel lines yet, have we? So maybe I need to use that. Well, if I have parallel lines, then I have all those parallel relationships, right? Alternate exterior, consecutive interior, alternate interior, and corresponding, right? Right? All right. So maybe I can use those angle pair relationships to say a pair of angles are congruent. That would be between my 2 lines, so I could be side angle side, right?
Angle C, and angle C.
So like this one and this one, it would have to be those two because it has to be between, say these 2 are congruent and these are congruent, so it has to be the angles between them. Y'all see that? Now, what reason are these 2 angles are congruent? Very good. Now, there's more than one angle C, aren't there? And more than one angle A. So remember, we need 3 letters then. So angle BCA is congruent to angle, what's the other one? Nope, A is the vertex. CAD or DAC, right? Remember, we need 3 letters to name an angle. Okay, and the vertex one goes in the middle, right? And that's because of alternate interior angles. Sorry, I had a fat pen, then it went to a skinny pen. So now I have side, angle, side. So can I say those triangles are congruent now? Yeah, because the angles between the 2 congruent sides. So now I can do my proof. Triangle ABC is congruent to triangle CDA by side, angle, side. So the angle has to be between 2 congruent sides. Can't be outside because there's no such thing as angle side side. That makes the ugly word. Okay? No such thing as angle side side. So the angle has to be between to use side, angle, side. Y'all with me? Y'all with me? Okay. Check out this picture. Looks like a car symbol. Like Pontiac. I don't even make those anymore. I don't even make those anymore. They stopped making them in 2010, I think. I know because my sister got one. She liked her Pontiac. All right, if you want to, if you just want to write the given in your statements, that's fine. Just have fun drawing that picture. I apparently did. You can see how mine got traced over a couple times. Yeah. So it tells me segment MP is congruent to segment NP, and they marked that, didn't they? MP is marked congruent to NP. Yep, they have those little tick marks. And then segment OP bisects angle MPN, and that's both given. OP bisects MPN. So OP is this vertical segment going down straight through the middle, and it bisects angle MPN. So basically angle P. What does that mean that it bisects it? Cuts it into two congruent parts. Exactly two congruent parts, right? Right? So basically both angle P's down here are going to be congruent to each other, right? So put that in a statement for me. Name those angles correctly. Angle, what's the name of those two angles? MPO to angle OPN. Y'all agree? By what reason? Why can I say those are congruent to each other? Very good. Definition of, I'm going to call it an angle bisector. Is it bisected an angle? If you just write definition of a bisector, that's perfectly okay. I was just trying to be specific. All right. Can I say anything else is congruent in my figure? Look carefully. Well, I'm trying to prove that triangle MOP, this left triangle, is congruent to NOP this time. OP is congruent to OP. They share that side in the middle, don't they? Whoops, I'm scrolling, not meaning to. So they share that. So segment OP is congruent to segment OP because of what? Reflexive property. Now, do I have enough to say those triangles are congruent to each other? Yes, because of reason. What reason? Side, angle, side. The angles in between two congruent sides consecutively. Good. So triangle MOP is congruent to triangle NOP because of side, angle, side. Any questions about that? Y'all are doing awesome. So triangle proofs really aren't that bad, right? There's not as much to remember. Basically, you're using a lot of properties you already know, and then you're seeing what you could use by which one of these reasons to say they're congruent to each other. All right. All right, don't write this down. Just look at it with me, okay? So here's a picture. It looks like a circle, and there's two lines that intersect that circle, and then we got these little chords here, and they're all intersecting at point M, looks like, except for these little segments on the side. It says segment and QS and RP pass through the center M of the circle. What can you say about triangle MRS, which is this left triangle, and triangle MPQ, which is the right triangle? Not a right triangle, but the right triangle on the right. So if it passes through the center, that means it's a diameter, correct? Right? We kind of know that. A diameter is a segment that passes through the center of a circle, right? Right? So that means each of these little segments to the center are called what? Radii, right? Radius, this is. No, they're radii. Okay? So what do we know about all radii? They're half the diameter and they're all congruent to each other, right? They're the equidistant from each point, from the center to each edge of the circle, each point on the edge of the circle, right? So all of these little segments are congruent. But do we know anything about these two segments? RS and QP? No. I can't say that these are congruent to each other. Is there anything else in these two triangles I can say are congruent to each other? The angles. Why are these angles congruent to each other? Whoa, that was tomorrow's notes. You don't need to see that yet. They're vertical angles, aren't they? Right? So now I can say these triangles are congruent because of what? Okay, so if I'm doing a proof, I would say these two angles are congruent by vertical angle theorem, right? And then I would have the triangles congruent by what? Side and side. Yeah. I'm gonna write congruent by side angle side. Okay. Because they didn't ask me to prove it, did they? Okay. We got one more theorem to learn today, and that is hypotenuse leg. Now, we know for any right triangle, the legs are the two sides of the triangle that make up the right angle. Correct? Correct? The legs are the two triangles, or the two sides of the triangle that meet to form a right angle. Check mark what we're doing today. Okay. So, the long side that's across from the 90-degree angle is called the hypotenuse. We know this. Correct? Correct? The one that does not touch the right angle, it's across from it, is called the hypotenuse. All right, find the hypotenuse leg theorem on your handout. It's the top one on the back side, isn't it? Right? Top theorem on the back. Highlight it, mark it, whatever. So you know that we covered it. So if we cover it, you're supposed to know it. Hypotenuse leg. All right, the hypotenuse leg theorem, you only need two things congruent. You need one leg, one pair of legs congruent, and the hypotenuse congruent for two triangles. So if you have right triangles, this only works for right triangles because right triangles are the only ones we have legs and hypotenuses for, right? Okay, so if you have a hypotenuse and a leg of one right triangle congruent to the hypotenuse and a leg of another right triangle, then the two triangles are congruent. So this is on because don't we already have an angle congruent, right? So this is the only thing you can really use angle side side for, and then we call it hypotenuse leg. Does that make sense? Okay, now I have these highlighted because it's confusing, and I don't like Z's, but it has them. So that's why my Z's have a line through them. Okay. What does this symbol mean?
Perpendicular.
Perpendicular. Okay. Let me just check something. This is about our last proof for the day before we do our practice. Okay? So I'm just going to do all these in my givens. And I highlighted my two triangles so because I'm trying to prove that triangle WYZ, this triangle on the left that I've highlighted yellow, is congruent to triangle XZY. So I highlighted them, color coded them so you can see which triangles we're trying to prove is congruent. Okay. So statements and reasons. They gave me a lot in the given. So again, this is one on a worksheet where they might split your givens up. So look for that in case they do it. WZ is perpendicular to ZY. All these horizontal ones. And XY is perpendicular to ZY. Those are all given. Now they didn't mark anything from the given, did they? On the picture. They did not. So that's my next thing I want to do is mark things. Okay, first of all, we can make this proof as long as short as we wanted to. Just depending on how we word everything. So first of all, WY, I'm going to mark it, which is this long thing right here. Stop. It's congruent to this long thing, right? They told me that, right? WY is congruent to XZ. Okay? So we already know that. And what do these perpendicular lines mean? That we form what kind of angles? They're right angles, right? What the ever loving? That's way too little. Excuse my technical difficulties. Jeez. Touch screens. All right. So them being perpendicular means I have right triangles here, right? Y'all see that? Right? So I can say triangle WYZ is a right triangle, and triangle XZY is a right triangle. And I can do that because of definition of perpendicular, right? Right? Those perpendicular lines form right angles, making those right triangles. Okay, well, if I can prove that another pair of legs are congruent, or a pair of legs, because right now, aren't those what I had marked congruent? Isn't that the hypotenuse of those triangles? Yes. Right, those are the hypotenuses. So if I can prove a pair of legs are congruent, then I could use hypotenuse leg, right? What's ZY? Yep. So they both share ZY, don't they? That's why you can see it kind of looks green where I've highlighted the blue and the yellow. Well, you can see it if you're not colorblind. But they share ZY, right? It's hard to see. I ain't gonna lie. I'm not making fun. It's just true. Okay, but they share that side down there, right? So that's a leg. So I can say ZY is congruent to itself because of the reflexive property. Now, do I have a hypotenuse and a leg congruent? Yeah, so now I can do my proof. Triangle WYZ is congruent to triangle XZY because of the hypotenuse leg theorem. You can only use hypotenuse leg for right triangles. So we had to establish these were right triangles because they didn't tell us that before I could use hypotenuse leg. Y'all see that? All right, it's time for practice. That's the end of notes for today. Have a good day. What the heck?